Hello folks and welcome to the classroom. Today's lesson, our learning goals are to derive exponent rules through multiplication and division. So the first thing we have to ask ourselves is, why do I care about exponents and exponent rules? Well, the first obvious thing is I could write out 3 times 3 times 3 times 3 times 3 times 3, right? But I could also just write 3 to the exponent 7. And this version here is so much easier to read, so much faster to write. So we like to stick with this kind of notation instead of the expanded form. The expanded form will have its uses, as you'll see today, but generally after today we're going to stick with this form because it's easier and it's faster. Okay, so we're going to start with some terminology, okay? So some quick terminology just so that we're all on the same page. When we are talking about exponents and exponent rules. Okay, so let's take my 3 to the 7 here. This number here is actually the exponent. Alright, so this number here is what we call the exponent. This number is what we call the base. So if you ever hear me refer to something as the base, it's always the bigger number, the number below the exponent. And all of it together is what we call a power. Okay, so all of it together is a power. The exponent is the little number, okay, and the base is the big number. Okay, good. So that's the terminology. So in terms of what it looks like. Now, what do all these numbers actually mean? So the base is the number being multiplied. Okay, so it is the number being multiplied. Like in our example up here, the base is 3 because we're multiplying 3 a bunch of times. And the exponent is how many times it's being multiplied. How many times we are multiplying. Excellent. So let's do some more examples. All right. Let me straighten out my camera. Excellent. So there we are. Okay. So, some examples. Example 1. 4 times 4 times 4 times 4 times 4. Well, the base, if we remember, is the number that is being multiplied. So the number that is being multiplied here is 4. Okay, so we know that the big number has to be 4. And how many times are we multiplying 4? Well, that's 1, 2, 3, 4, 5. So all of that is equivalent to this. Okay? Next is example 2. Example 2 is 10 times 10 times 10. Okay? And what number is being multiplied? Well, 10 is being multiplied. We see 10 here. And how many times do we see the number 10? We see it 1, 2, 3 times. So my power, which is all of it, is 10 to the exponent 3. Okay, and let's do one more example together here. Oh, forgot the little X on my example. Let's do 2 times 2 times 2 times 2. Okay. And so this is 2. 1, 2, 3, 4, 5. 5 times. Multiplying 2 by itself 5 times. Now remember, this only works if we are multiplying a number by itself. Okay? Alright. So, now here's where exponent laws and some cool exponent rules can come into play and help us out. Because that's all well and good. Now I can identify if I have a series of long multiplication with the same base, I can write it as an exponent, and that's great. But what if I want to try something a little bit trickier? What if I want to know the answer to this? What's that? Now, some of us might already know, but some of us might have some methods for solving this. I think that what we're going to do, we're going to prove some exponent laws here. So let's do this. I'm going to tell you the answer, and then I'm going to tell you how we get it. So the answer is actually 4 to the exponent 7. Okay? And now how do we get that? Well, let's do this. Let's write this in expanded form. So we're going to do the opposite of what we did on the last, with our last examples. So this is 4 times 4 times 4. 4 is our base. 4 3 times, because we have a 3 up there. Excellent. And then we multiply, right? We multiply by 4 times 4 to the 4. So 4 times 4 times 4 times 4 times 4. We have 4, and we have it 4 times because we have a 4 up there. Excellent. So, how many 4s do we have now? 1, 2, 3, 4, 5, 6, 7. Perfect. So it looks like my initial guess, or my initial answer was correct. So, basically, this is my answer. Now, if we are multiplying powers, so let's write out our rule here. So if we are multiplying powers with the same base, this is the important part, we add the exponents. Okay? And if, in case we forget, I'm going to draw over here our diagram where we write this is the base, this is the exponent, and this all is the power. Okay, I'm going to rewrite exponent a little bit so it's a little bit easier for us to read. There we go. Okay. Excellent. So, through our example here, we have just proven, or we have shown an example of addition or multiplication exponent laws. So in general, we can write this. Some base x with an exponent m when multiplied by another power with a base of x and an exponent n gives us x to the m plus n. Just like here, we kept the 4, right? And we added our exponents. 3 plus 4 is 7. There we go. Now, that's great. Multiplication, great. What about division? Right? What if I would like to solve some division problems? Some more complicated division problems that involve powers. Well, lucky for us, we have rules for that too. What if I wanted to know something like 4 to the 6 divided by 4 to the 3? Well, I'm going to tell you right now what our answer is, and then we'll see how we get there. That is 4 to the 3. Now, why? Well, again, let's recall. Let's rewrite this 4 to the 6. So 4 to the 6 equals 4 times 4 times 4 times 4 times 4 times 4. Right? We have 6 4s. 1, 2, 3, 4, 5, 6, because we have a 6 in our exponent, and our 4 is our base, so we have 6 4s. All right, and then let's write 4 to the 3. Three 4s, because exponent 3, base of 4. Okay, so another way we can write out this up here is 4 to the 6 divided by 4 to the 3 equals 4 times 4 times 4 times 4 times 4 times 4, all divided by 4 times 4 times 4. And now, since we are multiplying on both the top and the bottom, so we only have one term, we can start doing my favorite thing in math, which is crossing things off and eliminating. Okay? So, 4, 4, gone. All right. 4, 4, gone. All right. 4, 4, gone. All right. So what's left? 4 times 4 times 4. What's another way of writing that? 4 to the 3. Okay? And because of this, we now have a rule. We can derive a rule from this. We can say that any x to the m divided by any x to the n, remember these bases have to be the same, equals x to the m minus n. So if we have the same base, xx, or in our case 4, 4, all we have to do is subtract our two exponents. Just like we did up here. What's 6 minus 3? It's 3. Perfect. Well done so far. Now, let's do some practice. Okay? All right, first, here's what I'm going to do. I'm going to write out a bunch of examples, and then you are going to solve them. We're going to go over them again together, but I'm going to give you a second to solve them. I'm going to ask you to pause the video, whatever you want to do, to give you enough time to get some solutions down. So as you notice, I did the first one for you. That was an accident, but that's okay. We will work with it, and so just consider it a freebie. Alright, so now is going to be a good time. This is a 9, by the way. I know my 9s don't look very good. So consider this is a good time to pause the video. Alright, and we're back. So, as I said, I've already done the first one. 3 plus 2 is 5 because we have multiplication, right? So the first thing we have to do for our second example is identify, are we doing multiplication or division? We're doing division. We're doing multiplication. Do we have the same base? Yes, we do. Now all I have to do is add my exponents. So 11 to the 10. 6 plus 4 is 10. Excellent. So next, I'm doing division. So that means I'm going to be subtracting my exponents. And do I have the same base? Yes, I do. So now I just need to do 12 minus 11. So 3 to the 1, which we can also just write as 3. Because we always imagine there's a little 1 here if there's no exponent written. Okay, excellent. And last example, it looks a lot more like our previous when we were doing our proof. So again, we have division, so we're going to be subtracting. We have the same base here and here, so we do 9 minus 4, which gives us 5, so 7 to the 5. Excellent. Now, what if I wanted to do something even more complicated? What if I wanted to do the power of a power? Now, that sounds scary, but here's how it works. It's actually more simple than it sounds. Okay? So what if I wanted to solve this? A base of 8 with an exponent of 2, and all of that is to the exponent 3. Well, let's take it back a step. We can write this like this, right? Because this 8 to the exponent 2 is now our base for this power. Okay? So 8 to the exponent 2 times 8 to the exponent 2 times 8 to the exponent 2. And we know how to do this from last time, because we have all the same bases. So all we have to do is add our exponents, because we're multiplying. Okay? So 8 to the exponent 6. 2 plus 2 plus 2 is 6. So, basically, we have a new rule. In general, x to the m to the n. Now, it's very key that we have these brackets here. Otherwise, it might be mistaken for this n and m being part of the same power, but they're not. And this is x to the m times n, right? 3 times 2 is 6. All right. So, on my next, our next thing that we're going to do is we're basically done. We're just going to write out all of our general equations that we've come up with over the course of this lesson. So we have our multiplication rule, x to the m times x to the n equals x to the m plus n. We have x to the m over x to the n equals x to the m minus n. And finally, we have x to the m to the n equals x to the m times n. I'm going to give us a second to copy this down. I suggest you pause the video now. Make sure you have these in your notes. Excellent. Welcome back. I'm going to write out a couple more examples, this time using all three. Again, I'm going to ask you to pause the video once you start doing the examples. And don't worry, we will talk about them. So we're going to write all of the following as a single power. This is what your notebooks will, or your textbooks might tell you to do. Okay, so example 1. Seven to the 3 times 7 to the 3. So we're starting with some multiplication, then we're doing some division. I like the number 7, I guess. Then we got some power of a power, and we're going to jump back to some division. Okay, so it's at this point that I'll ask you to pause the video and do this at your own pace, and we'll come back in just a minute. All right, welcome back. So, let's give us some solutions here. So we have multiplication, same base. 12 times 4 plus, or 12 to the 4 plus 6 equals 12 to the 10. Alright, this one is, again, multiplication. We have the same base. So 7 to the 3 plus 3 equals 7 to the 6. Alright, we have division this time, and same base, so we know we're going to be subtracting. So that equals 7 to the 4 minus 1, because remember, we have an imaginary 1 if there is no exponent written. And that equals 7 to the 3. So now we have power of a power, so we take this as 2, 9 times 3, which equals 2 to the 27. Alright, and we have division, same base. So 3 to the 4 minus 3, which is 3. You could also write 3 to the 1, that's an acceptable answer as well. Both of them are totally correct. We have power of a power, so, because we have this outside of this bracket here, so 3 times 10, which gives us 6 to the 30. There's a little bit of 3 there, excellent. Okay, so thank you everybody for sticking around. What we learned today was all of our general rules for multiplying, dividing, and powers when we have the same base. Thanks for coming to class today, and we'll see you next time.